Hello, and welcome back to Fundamentals of Corporate Finance. We are continuing with Chapter 6. This is Part 4 of Chapter 6, and this is the last video. Again, this is Part 4 of Chapter 6, which deals with bonds. Bonds. And we're also continuing our discussion with coupon bonds. We left off with coupon bonds and we're finishing up with coupon bonds. So we know that coupon bonds are a type of bond that pays periodic interest payments known as coupons, and they are paid to the bondholders. Now, these interest payments are typically made semi-annually or annually, and they represent a fixed percentage of the bond's face value. At maturity, the bondholder receives the face value of the bond. Coupon bonds are also known as what we call bearer bonds because they are not registered in the issuer's books, and whoever physically holds the bond, they can collect the interest payments. And as you see here, this is actually coupon bonds, and you see the coupons to the right. So when when they're making the payment, they will take one of those coupons off and make their payment. Here in example 6.4a, computing the yield to maturity of a bond, we have a problem that we're starting off in this video. The problem is, consider the 9-year $1,000 note with a 3% coupon rate and semi-annual coupons described in example 6.3a. If this bond is currently trading for a price of $1,038.32, what is the bond's yield to maturity? What is the bond's yield to maturity? So the solution plan, we worked out the bond's cash flows in example 6.3a. From the cash flow timeline, we can see that the bond consists of an annuity of 18 payments of $15. Remember that? Paid every 6 months, and one lump sum payment of $1,000 in 9 years, which equates to 18 6-month periods. We can use equation 6.3a to solve for the yield to maturity. However, we must use 6 months intervals consistently throughout the equation. To execute, because the bond has 18 remaining coupon payments, we compute its yield, Y, by solving equation 6.3 for this bond. So you see $1,038.32 equals 15 times, then you have the fraction 1 over Y. And then you have the parentheses 1 minus 1 over 1 plus Y in parentheses to the 18th power plus 1,000 over 1 plus Y in parentheses to the 18th power. So we can solve it by trial and error, financial calculator, or a spreadsheet. To use a financial calculator, we enter the price we pay as a negative number for the PV. It is a cash outflow. The coupon payments as PMT and the bond's par value as its FV. Finally, we enter the number of coupon payments remaining, which is 10, as N. So you see the financial calculator version, and then you see the formula for the Excel spreadsheet that you would use. To execute, therefore, Y equal 1.26%. Because the bond pays coupons semi-annually, this yield is for a 6-month period. We convert it to an APR by multiplying by the number of coupon payments per year. Thus, the bond has a yield to maturity equal to 2.52% APR with semi-annual compounding. Evaluate, as the equation shows, the yield to maturity is the discount rate that equates the present value of the bond's cash flows with its price. So let's review. The coupon rate of a bond refers to the fixed annual interest rate that the issuer pays to the bondholder. And it is typically expressed as a percentage of the bond's face value. Now, this rate remains constant throughout the life of the bond, and it also determines the periodic interest payments known as coupon payments. And that's what the bondholder receives, the coupon payments. On the other hand, the yield to maturity of a bond, it represents the total return anticipated on a bond if it is held until its maturity date. Okay? So the yield to maturity of a bond represents the total return anticipated on a bond if it is held until its maturity date. So the YTM, which is yield to maturity, it takes into account not only the periodic coupon payments, but also any capital gains or losses realized if the bond is bought at a discount or premium to its face value. It is essentially the annualized rate of return that an investor can expect to earn on a bond if all the coupon payments are received as scheduled and the bond is held until maturity. So the relationship between the coupon rate and the yield to maturity, the YTM, it is straightforward. So when the bond's market price is equal to its face value, the coupon rate and the YTM, or the yield to maturity, they're the same, okay? So if the bond is purchased at a discount, meaning below face value, the YTM will be higher than the coupon rate. So if the bond is bought at a premium, meaning above face value, the YTM will be lower than the coupon rate. Okay? So again, the coupon rate represents the fixed interest payment relative to the bond's face value, while the YTM accounts for both the coupon payments and any capital gains or losses upon maturity, providing a more comprehensive measure of the bond's return. So coupon rates are predominantly affected by government set interest rates. Now, if the government raises the minimum interest rate to 6%, existing bonds with coupon rates below 6%, they will experience a decrease in value. Now, sellers of existing bonds must lower their market price to offset the reduced coupon payments compared to newly issued bonds. Buying a bond at premium involves purchasing it for more than its par value, while buying at a discount, it means paying less than its par value. So despite the purchase price, coupon payments remain unchanged. The yield to maturity, or the YTM, it is a projected rate of return that assumes the bondholder will retain the bond until it matures and reinvest all interest payments at the same rate. Therefore, the yield to maturity encompasses the coupon rate as part of its calculation. And here is another problem. Example 6.5, computing a bond price from its yield to maturity. Consider again the 5-year $1,000 bond with a 2.2% coupon rate and semi-annual coupons in example 6.4. Suppose interest rates drop and bonds yield to maturity decreases to 2%, expressed as an APR with semi-annual compounding. What price is the bond trading for now? And what is the effective annual yield on this bond? Again, what price is the bond trading for now? And what is the effective annual yield on this bond? Solution plan. Given the yield, we can compute the price using equation 6.3. First, note that a 2% APR is equivalent to a semi-annual rate of 1%. Also, recall that the cash flows of this bond are an annuity of 10 payments of $11, paid every 6 months, and one lump sum cash flow of $1,000, which is the face value, paid in 5 years, which is 10 6-month periods. In Chapter 5, we learn how to compute an effective annual rate from an APR using equation 5.3. We do the same here to compute the effective annual yield from the bond's yield to maturity expressed as an APR. Using equation 6.3 and the 6-month yield of 1%, the bond price must be where you have P equal 11 times 1 over 0.01, and then you have in parentheses 1 minus 1 over 1.01 to the 10th power, end of parentheses, plus 1,000 over 1.01 to the 10th power, equal $1,009.47. $1,009.47. We can also use a financial calculator or spreadsheet. Here in this example, it shows the financial calculator and how you would use it, and also the formula that you would use in an Excel spreadsheet. So the effective annual yield corresponding to 1% every 6 months is, then you have in parentheses, the 1 plus 0.01 in the parentheses to the second power minus 1 equal 0.0201 or 2.01%. To evaluate, the bond's price has risen to $1,009.47, lowering the return from investing in it from 1.5% to 1% per 6-month period. Interest rates have dropped, so the lower return brings the bond yields into line with the lower competitive rates being offered for a similar risk and maturity elsewhere in the market. And that's the end. That's the end of part 4 and the end of this lecture. Thank you for watching.